Now we had the first derivative test. That's where we saw if a function was increasing before a stationary point and decreasing after, then we knew it was a maximum. Or if it was decreasing before, I'll just draw a little picture. So let's say you found your derivative, it was 0 at x equals 2. If it's decreasing before and increasing after, that really tells us it's a minimum. The first derivative test is the best way to tell if something is a minimum or a maximum. The main misunderstanding about the second derivative test is you think that the second derivative test is about concavity. It's just another test to tell if something's a maximum or a minimum. The second derivative test says that if you found out that x equals 2, that's where, so f prime of 2 is equal to 0, and you decided not to do the first derivative test at all. So we don't know that it's a minimum. But then, on our second derivative, let's say our second derivative, we found that it was equal to 0 at 3, and before 3, it was concave down. Actually, what did I have in my arrows? I had a minimum. Let's do it this way. Let's keep it with what we had before. Let's say you found it was positive, and after it was negative. Okay? If this was the case, there's enough information here to tell us that this is a minimum. Okay? Because here's 2, we would say that f double prime of 2, because it's positive, is greater than 0. The only way that it can be concave up at 2 and a tangent equal to 2 is if it was a minimum. But I find the second derivative test not as easy to visualize, because if you did the first derivative test and saw it was going down and then going up, how easy is that to tell it's a minimum? Okay? But with the second derivative test, if the first derivative is equal to 0, which we said was at 2, and the second derivative is greater than 0, meaning that it's concave up, the only possibility at 2 would be that has to be a minimum. And conversely, if you found out it was 0, let's say you had another point over here at 5, and it goes down after 5, that would be a local max. And at 5, the second derivative was negative, meaning it's concave down, then you would have a maximum there. Do I have things labeled minimum in both places, don't I? I've got to change one. Okay, this one. You won't even tell afterwards. Check this out. Here we go. There we go. Make it just the right size. Put it. Oh, like it never happened. Yes? I have no idea.